GitLab is the faster path from idea to software. It's more than a code repository. It's one workflow that brings development, security, and operations teams together. No walls, no endless feedback loops. Use GitLab end-to-end or integrate it with the tools you love. And it lets you eliminate the rest to help reduce costs and boost productivity at the same time without trade-offs. With GitLab, teams can build software faster, automate software delivery, shorten cycle times, and increase developer productivity. And security is built in, not bolted on. Scan for vulnerabilities with every code push, automatically. It's the entire development process, all in the same place where everyone works. Because we're on this path together. The path from idea to collaboration to higher performing teams. With one comprehensive, innovation-driving, fast and secure DevSecOps platform. Software faster. GitLab.
Hi, everyone. Welcome to our webinar session today. We're glad you joined us. We're going to give people just another minute or so to jump in, and then we'll get started. All right, let's go ahead and jump in. Thanks again for joining us. We're excited to have you with us today. Our content today, as you can see, and as you've signed up for, is Intro to GitLab, CI/CD. We're excited to go through the content with you. Before we jump in, I wanted to go through just a couple of housekeeping items. First off, this webinar is being recorded, so you can look for that recording to be sent to you here in the next day or so. Additionally, if you have any questions that come up throughout this presentation, please feel free to put those in the Q&A portion of Zoom. We have some folks online today that'll be able to help answer those, and then Justin, our presenter today, will be able to answer a few of those at the end. So without further ado, I'll pass it over to Justin, who's one of our customer success engineers here at GitLab.
Thanks, Taylor. So hello and welcome to today's webinar. We're going to be covering an introduction to GitLab CI/CD today. And like the title says, this webinar is designed for teams getting started with GitLab CI/CD. But regardless of where you are in your GitLab journey, I'm sure you'll find some of the topics we cover useful and interesting. If you're after some more advanced CI/CD content, covering detailed setup and configuration for CI/CD and runners, I recommend that you take our one-day CI/CD course for this. If it's a more in-depth usage and best practices for project management that you need, we also have a one-day project management course for that too. And finally, if it's initial system setup and management that you need enablement on, our one-day system administrator training course is for you. So with that being said, let's get started with today's webinar, an intro to GitLab CI/CD. So on the agenda for today, we have a quick overview of GitLab before we get into the CI/CD related topics, where we'll cover a definition of CI/CD, an overview of CI/CD with GitLab, and then we'll get into the more detailed parts like setup and runners. And we'll finish up today's session with some Q&A. Great, so let's get started with an overview of GitLab. GitLab is the first and only true DevSecOps platform. It's a single application with one user interface, a unified data store, one permission model, and security embedded throughout the entire DevOps lifecycle. In a single application, it combines the ability to plan, develop, secure, release, and operate and monitor software. Being in a single application makes it easier to use and maintain, while offering complete visibility and traceability throughout the software development lifecycle. With GitLab as a partner, every team in your organization can collaborate in a single solution to manage the end-to-end development lifecycle, delivering more value faster, increasing visibility, quality, and security, all while removing context switching and non-value generating tasks. So what exactly is CI/CD? CI/CD stands for continuous integration and continuous delivery or deployment. It can be thought of as a culture, a methodology, a set of operating principles, and a collection of practices that enable application development teams to deliver code changes more frequently and efficiently. The implementation is also known as the CI/CD pipeline. If we look at the continuous integration or CI portion, CI is a development practice where developers integrate code into a shared repository frequently, preferably several times a day. Each integration can be verified by an automated pipeline of scripts that build and automatically test before merging them into the main branch. While automated testing is not strictly part of CI, it is typically implied. Now, in terms of continuous delivery, or CD, CD is the practice of keeping your code base deployable at any point. Beyond making sure your application passes these automated tests, it has to have all of the configuration necessary to push it into production. Many teams then do push changes that pass the automated tests into a test or production environment immediately to ensure a fast development loop. If we look at CD as continuous deployment, it's actually closely related to continuous integration, but pushes changes to production automatically. It refers to keeping your application deployable at any point, or even automatically releasing to a test or production environment if the latest version passes all automated tests. When combined, this whole CI/CD pipeline leads to low-risk releases that can be performed at any time on demand, a faster time to market, as the usual for development cycle that takes weeks or months is greatly improved, when teams working together to automate the build and deployment, environment provisioning, and regression testing processes. We also get higher quality because when developers have automated tools that discover regressions within minutes, teams are free to focus their effort on research, user research, and higher level testing activities such as exploratory testing, usability testing, and performance and security testing. So by building a deployment pipeline, these activities can be performed continuously throughout the delivery process, ensuring quality is built into your application from the beginning. You'll also see costs lower because investing in build, test, deployment, and environment automation, we substantially reduce the cost of making and delivering incremental changes to software by eliminating many of the fixed costs associated with the release process. And this all leads to better products, as we can get feedback quicker from users throughout the delivery cycle based on working software. Ultimately, all of this also results in happier teams, thanks to the fact that continuous delivery makes releases less painful and reduces team burnout. Furthermore, when we release more frequently, software delivery teams can engage more actively with users, learn which ideas work and which don't, and see firsthand the outcomes of the work that they've done. So why use CI/CD? Well, with GitLab's out-of-the-box CI/CD, you can spend less time maintaining and more time creating. CI detects errors quickly, so you can fix them while they're fresh in your mind. CD delivers value quickly and more often, meaning you get fast feedback on what your end users care about. CI reduces integration problems as smaller problems are easier to digest, and it ensures that problems don't compound. CD ensures that every change is releasable, and this lowers the risk of each release and allows releases to be boring. CI allows teams to develop faster as more confidence among the developers allows for less bottlenecking. On the flip side, the negatives of not using CI/CD include having too many integration points, so connecting CI/CD to all of the different tools in a DevOps toolchain is confusing and keeps adding more steps and more points of failure to the whole process. We also see brittle tools, so where we're spending more time maintaining and actually updating these tools than creating new features. And finally, you can see slow modernization. We want to leverage microservices and cloud-native development, but we spend too much time putting out fires. So this image shows you the GitLab flow. The GitLab flow is a comprehensive and efficient workflow for the application development within GitLab, focusing on the entire DevSecOps lifecycle. It incorporates best practices, forming an inner and outer feedback loop for continuous improvement. Here's a quick summary of GitLab Flow's key components. We start with planning, which involves issue tracking, merge requests, epics, milestones, iterations, and release management. Also, our AI feature GitLab Duo aids in issue enrichment, summarizing comments, and visualizing workflows with issue boards. Moving into merge requests and pushing code, developers collaborate on solutions within merge requests, utilizing features like tagging, inline suggestions, and code explanations. Pipelines automatically build, test, and deploy code, facilitating the whole review process. You can see that the GitLab flow works to shift security left as well, as security scans are integrated into pipeline to detect and address vulnerabilities early in the development lifecycle. GitLab offers various built-in security scanners and tools. In terms of reviewing features, a review environment is established to continuously review and adjust feature branches as required. This is another place where our new AI offering, GitLab Duo, can enhance communication between authors and reviewers. When it comes to deploying applications, GitLab Flow supports both continuous delivery and continuous deployment. Various deployment techniques, including canary and blue-green deployments, can be employed to release code efficiently. For monitoring applications and DevSecOps processes, GitLab provides tools for monitoring applications, error tracking, alert management, incident handling, and compliance tracking. These tools all help to ensure application stability and security. In terms of continuous improvement, GitLab offers end-to-end process metrics and dashboards, including value stream analytics and DORA metrics to support continuous improvement efforts. GitLab Duo also provides additional predictive analysis. So as we've seen, CI/CD is a continuous method of software development where you continuously build, test, deploy, and monitor iterative code changes. This iterative process helps reduce the chance that you develop new code based on buggy or failed previous versions. GitLab CI/CD can catch bugs early in the development cycle and helps ensure that all code deployed to production complies with your established code standards. Let's now jump into an overview of how CI/CD works in GitLab. The GitLab pipeline is the fundamental building block of continuous integration, delivery, and deployment. A pipeline will be created when a new push is made to the GitLab repository. The pipeline will immediately run when there is an idle GitLab runner, or will be put in a queue if all available runners are being used by someone else. Continuous integration is built in and works to integrate code provided by your team in a shared repository. Developers share new code in a merge request, and the request triggers a pipeline to build, test, and validate the new code prior to merging the changes within your repository. Continuous delivery ensures the delivery of CI validated code to your application via structured deployment pipelines. So together, CI and CD help your team deliver faster results for your customers and stakeholders. CI and CD must work together to help your team build quickly and effectively, and are critical for fully optimized software development. Pipelines in GitLab consist of two key components, where we've got jobs and stages. Jobs specify the tasks to be performed within the pipeline, such as code compilation or testing. Stages, on the other hand, determine the order and conditions for running these jobs. For example, you might have stages that compile code before stages for running tests. By default, a pipeline includes 3 predefined stages. You've got build, test, and deploy. Importantly, you don't need to create a job for every stage, and stages without jobs will be skipped. Jobs are carried out by runners, and multiple jobs within the same stage can run simultaneously if there are enough available runners. The pipeline progresses to the next stage only if all jobs in the current stage succeeded. If any jobs in a stage fail, the subsequent stages typically do not run, and the pipeline terminates early. In most cases, pipelines run automatically without manual intervention after creation. However, there are situations where manual interaction within a pipeline is possible. There are many different ways to trigger a GitLab pipeline. So you can trigger a pipeline to run in several ways, depending on your workflow and requirements. And some common methods to trigger a GitLab pipeline include pushing code changes to a branch, creating or updating a merge request, scheduling pipelines at regular intervals, manually triggering pipelines via the GitLab web interface. You can use the GitLab API to trigger pipelines programmatically. You could configure webhooks to trigger pipelines on specific events. You could also set up external triggers through the GitLab CI/CD API. And you can also define dependency pipelines to trigger downstream stages as well. So now let's look at GitLab CI/CD setup. Here's a very basic example of a GitLab CI YAML file, which is written in YAML syntax and stored in the root of a project and version controlled along with the rest of your code. In the GitLab CI YAML file, you can define the scripts that you want to run, other configuration files and templates that you want to include, dependencies and caches, the commands that you want to run in sequence and those you want to run in parallel, the location to deploy your application to, and whether you want to run the scripts automatically or trigger any of them manually. So this file has just a few sections to specify the jobs and stages of the pipeline. Let's take a look at each one of them. If we look at the top red box, this section defines the stages for the pipeline. Here you can see that they are specified as build and deploy. And if you look at the middle red box, this section represents the build job. You can see that the stage is defined as build, followed by the script for the job and an only statement. If you look at the bottom red box, this section represents the deploy job. And you can see that the stage is specified as deploy. And there's also an environment, variables, and only statement included for this job as well. There are many other sections and types of content that you can include inside the YAML file, but for this webinar, we'll be focusing on the most basic ones. our full CI/CD course goes into more depth on the GitLab CI YAML file setup. In GitLab CI/CD pipelines, a stage is a logical division of your pipeline where you can group related jobs together. Each stage represents a specific phase or step in your CI/CD process, such as building, testing, deploying, or any other tasks that you need to perform. Some things to note about stages in a GitLab CI/CD pipeline are that stages are executed in a defined order from top to bottom in the GitLab CI YAML config file. The pipeline moves on to the next stage only if all jobs in the current stage complete successfully. Jobs within the same stage can run in parallel, which can significantly speed up your pipeline execution as well. You can define both manual and automatic jobs within a stage. Manual jobs require manual intervention to be triggered, while automatic jobs are triggered automatically. Jobs within a later stage can depend on the successful completion of jobs in earlier stages too, and this allows you to ensure the tasks are executed in the correct order. In a GitLab CI/CD pipeline, a job represents a specific task or unit of work that needs to be executed as part of the pipeline. Each job is defined within a stage in the GitLab CI YAML configuration file and is responsible for performing a particular action, such as building code, running tests, deploying applications, or performing other tasks related to the software development and deployment process. Each job includes a script section where you specify the commands or scripts that should be executed as part of that job. These scripts typically perform the specific task associated with the job. GitLab CI/CD pipelines rely on various keywords and configuration settings in the GitLab CI YAML file to define their structure and behavior. You can have global keywords that configure pipeline behavior and job keywords to define job behavior. In a GitLab CI/CD pipeline, the image keyword is used to specify the Docker image that should be used as an execution environment for a particular job within the pipeline. This keyword allows you to define the base image or container in which the job script or commands will run. You can use various Docker images available on Docker Hub or specify your own custom images if needed. The image keyword is a powerful feature in GitLab CI/CD that allows you to easily define the runtime environment for your jobs, ensuring consistency and reproducibility in your CI/CD processes. In a GitLab CI/CD pipeline, the services keyword is used to define additional Docker containers that should be run alongside the primary jobs container. These additional containers provide services or dependencies that the job requires to execute successfully. The services keyword is particularly useful when you need to set up auxiliary containers such as databases, caches, or other services for your CI/CD jobs to complete. Here we're calling the Postgres layer to add a database service to our base image. The variables keyword is used to define environment variables that are made available to the jobs within a specific stage or globally for all jobs in the pipeline. These environment variables can be used to store configuration settings, secrets, or any other data required during the execution of your CI/CD jobs. You can also define job-specific variables within individual jobs, and they will override any global variables with the same name. So now we're going to work on building a pipeline together. In this example, you can see that for image, we're using a Kubernetes latest container. For services, we've added in Postgres. For stages, we've got a build, test, and deploy stage. And for jobs, we have one job present, which is the deploy code job. This will deploy the code as part of the deploy stage. As you can see, we're setting all configurations in the GitLab CI YAML file. In GitLab CI/CD, the environments keyword is used to define and manage deployment environments for your application. Deployment environments are typically used to specify where your application should be deployed or tested after a successful pipeline run. These environments can represent various stages in your deployment, development, or production pipeline, such as development, staging, or production. The when keyword that's defined here defines when this stage is run, in this case manually. It can also be set to on success, which will execute job only when all jobs from the prior stage have succeeded. This is the default. It can also be set to on failure, where it'll execute a job only when at least one job from the prior stage fails. Or it can be set to always, to execute the job regardless of the status of jobs from prior stages. Here we're saying deploy to all branches except main by using the only and except keywords. We've since released an improved rule syntax that is more powerful than the only except keywords. Many advanced uses are possible. Rules provide a powerful way to define conditions for when a job should run in a pipeline. The rule syntax is quite flexible and allows you to specify a set of conditions that determine job execution. These conditions can be based on various factors, including branches, tags, changes to specific files, pipeline variables, and more. Only and except are great for simple job rules. However, you may encounter more complex situations. In this case, rules are a great option. As you can see, the rule section of this example, we're showing the same rule as the slide before, but this time the rule instead of only and except. Rules are evaluated in order until their first match, and then when matched, the job is either included or excluded from the pipeline, depending on configuration. If included, the job also has certain attributes added to it. We cover more of this in our advanced workshop. So, as we covered, whenever you're writing jobs, you will always have the script keyword defined. Script is the only keyword that a job actually needs. Without it, a job wouldn't have anything to do. But in addition to script, there is also before script and after script keywords. Before script runs before the script statement, but in the same shell. Its main purpose is to run steps that are necessary in order for the script statement to execute properly. A good example would be a before script installing the AWS CLI, while the script then executes AWS CLI commands. And like the before script, there is an after script, which is also optional. After script runs after the script keyword. It's worth noting that after script statements are executed in a separate shell. A good example of uses for after script would be cleanup. You can also evaluate the exit code of script in after script and have additional job behaviors depending on the result. From a pipeline perspective, a job is evaluated as a success or failure based on the exit code in the script statement only. In GitLab CI/CD pipelines, both cache and artifacts are features used to optimize and manage the storage of files and dependencies between pipeline runs. However, they serve different purposes and are used in different scenarios. The primary purpose of caching is to speed up pipeline execution by reusing previously downloaded or generated files or dependencies. You typically use caching for dependencies that do not change frequently between pipeline runs, such as packages, libraries, or build artifacts. You use the cache keyword in your GitLab CI YAML file to specify which files or directories to cache. In terms of behavior, when a job runs, GitLab checks for an existing cache. If one exists and is up to date, it's restored, saving time and resources. If the cache is missing or outdated, GitLab generates a new cache for the job to complete. For artifacts, they are used to capture and store specific files or directories generated by a job, making them available for download or use in a subsequent pipeline stage. Artifacts are useful when you need to pass build artifacts, test results, or other job-specific files to later stages or access them in the GitLab UI. For syntax, you use the artifacts keyword to specify which files or directories should be treated as artifacts and where they should be stored. In terms of behavior, after a job completes, GitLab packages specified artifacts and stores them. These artifacts can be accessed via the GitLab UI or can be passed to downstream stages in the pipeline. Artifacts are typically retained until the pipeline finishes, but you can also set expiration policies if you need to. So in summary, cache is used to speed up execution by reusing dependencies, while artifacts are used to capture and store job-specific files for further analysis or deployment. Both features contribute to optimizing GitLab CI/CD pipelines and ensuring efficient and reproducible builds and deployments. So now to go back to our GitLab CI YAML file, you can see that cache, artifacts, environments, when, and only keywords were all added. We've also added a new job called Build It to the build stage. In GitLab CI/CD pipelines, tags are a way to label and identify specific GitLab runners for job execution. Runners are the machines or environments where your CI/CD jobs are executed. By assigning tags to runners, you can control which runners are eligible to run specific jobs in your pipeline. This is particularly useful when you have runners with different capabilities, or when you want to ensure that certain jobs are executed on specific types of runners. You can see now that we've also added the two tags OSX and iOS to our build job. Because we've added these two tags to our build job, in the pipeline, the job will be executed on a runner that has at least one of these two tags. This means that the job can be run on a runner tagged with either OSX or iOS, or on a runner that has both tags. So speaking of runners, let's take a deeper look into how they work in GitLab. So just to recap on the purpose of the GitLab CI YAML file and how it works with GitLab Runners. The GitLab CI YAML file is a configuration file that defines the structure and behavior of your CI/CD pipeline. It specifies the stages, jobs, scripts, dependencies, and other settings to your pipeline. This file is stored in your GitLab repository and is used to instruct GitLab CI/CD on how to build, test, and deploy your code. A GitLab runner, however, is a separate component that is responsible for executing the jobs defined in your GitLab CI YAML file. Runners can be installed on various types of machines or cloud environments, such as virtual machines, Docker containers, or dedicated servers. Runners listen for new pipeline jobs, fetch the jobs associated with GitLab CI YAML configuration, and execute the defined tasks. So, as we know, GitLab Runner is an application that works with GitLab CI/CD to run jobs in a pipeline. If you use GitLab.com, you can run your CI/CD jobs on SaaS runners hosted by GitLab. These runners are managed by GitLab and are fully integrated with GitLab.com. By default, these runners are enabled for all projects, but you can disable these runners if you have the owner role for the project. Alternatively, you can install GitLab Runners and register your own runners on GitLab.com or on your own instance. To use self-managed runners, you install GitLab Runner on infrastructure that you own or manage, and it can be installed on any platform where you build Go binaries. In the GitLab UI, there are 3 types of runners based on who you want to have access. So firstly, you have shared runners, which are available to all groups and projects in a GitLab instance. You have specific runners, which are associated with specific projects. And typically, a specific runner are used for one project at a time. You also have group runners, which are available for all projects and subgroups in a group. With shared runners are available to every project in a GitLab instance. You should use shared runners when you have multiple jobs with similar requirements. So rather than having multiple runners idling for many projects, you can have a few runners that handle multiple projects. Shared runners process jobs by using a fair usage queue, and this queue prevents projects from creating hundreds of jobs and using all available shared runner resources. The fair usage queue algorithm assigns jobs based on the projects that have fewest number of jobs already running on shared runners. Specific runners are used when you want to use runners for specific projects. For example, when you have jobs with specific requirements, like a deploy job that requires credentials, or projects with a lot of CI activity that can benefit from being separate from other runners. You can set up a specific runner to be used by multiple projects as well. Specific runners should be enabled for each project explicitly. So if we're to look at tagged versus untagged runners, tagged runners are explicitly assigned to jobs based on their tags specified in the GitLab CI YAML file. This allows for fine-grained control over runner selection for specific jobs. Untagged or shared runners are available for any job that does not have specific tags, or when the job's tags do not match any runner tags. They're typically used for jobs that can run on a general purpose runner without specific requirements. Choosing between tagged and untagged runners depends on your project's needs. Tagged runners are useful for specialized tasks, while untagged or shared runners are convenient for general tasks and when you don't require any specific runner characteristics for your job. So as you know, we have to be careful with sensitive information and prevent runners from revealing sensitive information. To facilitate this, you can protect runners so that they don't reveal any sensitive information. When a runner is protected, the runner picks jobs created on a protected branch or protected tags only and ignores other jobs. GitLab recommends protecting the runner if it contains deploy keys or any other sensitive capabilities. You can protect a runner in your GitLab project settings. So to look now at some common executors, GitLab runner executors are components that define how jobs in a CI/CD pipeline should be executed on the underlying infrastructure. GitLab offers several types of executors, each tailored to different scenarios and requirements. Here are some common GitLab runner executors. You have your shell executor. So this executor uses the default shell of the runner's host machine to actually run the jobs. It is simple and works well for basic use cases, but may lack isolation and security compared to other executors. The Docker executor runs jobs inside Docker containers, providing isolation and also reproducibility. You can define custom Docker images or use existing ones to create specific runtime environments for your jobs. You also have Docker Machine Executor. This executor uses Docker Machine to create and manage Docker containers on remote hosts. It's useful if you want to run jobs on machines that are not directly accessible from the GitLab runner host. You also have the Kubernetes executor, which leverages Kubernetes clusters to run jobs in isolated pods. It's well suited for containerized applications and provides scalability and resource management as well. If we're to look at some less common executors, we've got VirtualBox. So this executor is similar to the Parallels executor, but is used with VirtualBox virtual machines, and it's suitable for running jobs on a local development environment. The Parallels executor is designed for macOS runners and enables jobs to run in virtual machines managed by Parallels Desktop. And finally, the SSH executor allows jobs to be executed on remote machines over SSH connections. It's useful when you want to utilize existing infrastructure or when you need more control over job execution. The choice of executor depends on your specific requirements, infrastructure, and the level of isolation, security, and reproducibility that you need for your CI/CD jobs. Each executor has its advantages and trade-offs, so it's essential to select the one that best aligns with your project's goals and constraints. Let's now take a quick look at package and container registries in GitLab. In GitLab, package and container registries are integrated services that allow you to store and manage software packages and container images. These registries are tightly integrated with GitLab CI/CD pipelines and provide a convenient way to store, version, and distribute software artifacts. In terms of package registry, the package registry in GitLab is designed to store and manage different types of software packages, such as libraries, dependencies, and application components. It supports multiple package managers, and when you build and test your code using GitLab CI/CD pipelines, you can publish packages to the package registry as build artifacts. The package registry allows you to version and distribute packages within your organization, improving software dependency management and reducing the reliance on external package repositories. On the other hand, with container registry, the container registry in GitLab is used for storing and managing Docker container images. It is also tightly integrated with GitLab CI/CD, making it easy to build, test, and deploy containerized applications directly from GitLab. When you build a Docker image as part of your CI/CD pipeline, you can push these images to the container registry. The container registry provides a private and secure repository for your container images, making it suitable for use in production deployments. You can also use the container registry to distribute container images to various environments, such as development, testing, and production. Both the package registry and container registry offer versioning and access control features, ensuring that you can manage and share your software artifacts within your organization securely. These registries simplify the process of storing and distributing packages and container images, making it easier to manage your dependencies and streamline your CI/CD workflows within GitLab. There are a number of ways that you can authenticate and pull from and push to a container registry or package registry in GitLab. To use an access token to pull from and push to a GitLab container registry or package registry, you'll need to include the token in your authentication when interacting with these registries. These can be personal, project, or group access tokens. GitLab deploy tokens are also a secure way to grant read-only or read-write access to your GitLab container registry or package registry without exposing your personal credentials. You can also use GitLab CI/CD predefined variables to simplify authentication and interact with GitLab container registry and package registry within your CI/CD pipelines. These predefined variables provide credentials and information necessary for registry access. Now, finally, just to wrap up today's webinar, we want to make you aware of how GitLab offers many different ways to maximize the value of your investment through training, access to SMEs, and best practices. We have a whole host of self-paced learning and certification available on levelup.gitlab.com. We have private instructor-led training available with our in-house experts. And we also have monthly webinars and workshops. And last but not least, we have myself and members of my team, customer success engineers and managers, who you can schedule some time with to discuss your technical, resource, training, and enablement needs. So now I believe Taylor has some questions for me that may have come up through today's webinar. So over to you, Taylor.
Thanks, Justin, and appreciate you going through that content. First off, I did just open up a feedback poll. We'd love to get some feedback from you on today's session. Just a couple of quick questions. If you would want to fill that out, that would be great. And with that, yes, Justin, we did have a few questions that came through. I'm going to pose those to you now. The first one, what is the primary benefit of using GitLab CI/CD compared to other CI/CD solutions?
Sure. So in order to complete all of the required fundamentals of full CI/CD, many CI platforms rely on integrations with other tools to fulfill those needs. Many organizations have to maintain costly and complicated tool chains in order to have full CI/CD capabilities. And this often means maintaining a separate SCM like Bitbucket or GitHub, and connecting to separate testing tools that connect to their CI tools, that then connects to a deployment tool like Chef or Puppet, that then also connects to various security and monitoring tools. So instead of just focusing on building great software, organizations have to also maintain and manage a really complicated tool chain. Whereas on the other side, GitLab is a single application for the entire DevSecOps lifecycle, meaning that we fulfill all of the fundamentals for CI/CD in one single environment.
Awesome. That makes a lot of sense. Next question here. How can I view the status of my pipeline and jobs?
Yeah, sure. So you can do this from the UI. So if you're in the GitLab UI, on the left-hand navigation bar, you can just go to Build and Pipelines. From there, you're going to see a full list of pipelines. You'll see those that have run in the past, and you might see some that are currently running. You can click into any of them by simply clicking on the hashtag and the number that's beside them. And once you're there, you're going to see the pipeline graph that we've seen in today's presentation. And by clicking on any of the jobs that you see when you're in there, you're going to be able to see the jobs details in a kind of log style output, which is really helpful too.
Great. Next one that came up here. When will a job in a pipeline not run?
Sure. So there's a number of times when a job won't run. So specifically when none of the rules that are defined for the job evaluate to true, it's not going to run. Or when a rule does evaluate to true, but it has a clause of when never. Or when no rules are actually defined for the job at all, but a when never clause is specified.
Great. And then last one I'm seeing here, can I make a job in my pipeline a manual step?
Yeah, for sure. So this is done by using the keyword when and giving it a value of manual. And the result is that the only time this job will actually execute is when someone comes to the UI in GitLab and clicks on the little play button that appears on the job in the pipeline graph. It's worth noting that that play button will actually only show to those people who have the permission to run it, unless you haven't defined who can run it, in which case any developer can run it.
Great. Thanks for going through those. And thanks everyone for joining us today. With that, we will wrap up today's session. We appreciate you taking some time to go through this Intro to CI/CD webinar with us. And please keep your eye out for future sessions like this. We'd love to host you again. With that, we'll wrap things up. Thanks, everybody.
Thanks, folks.